In order to start this next problem, which I began on the last video, I'm going to go back to the theorem, kind of briefly remind everybody what I was doing, is that we were talking about the area underneath the curve, the area in black right here, and we want the area in the black to equal the area in red. So there's some value c that when you plug it into the function, that becomes its height, and the height times the base, that rectangle, the rectangle in red, is equal to the area underneath the curve. And so what we're going to do, and I've gone ahead and drawn this curve, is we have 9 over x cubed. And what we're doing is we're going to look and find this area underneath the curve. And what I want to know is, when does that area underneath the curve equal, what is that area first of all, and then when, or what value of c, okay, so maybe it's right here, okay, what value of c, if I was to draw a rectangle in, would I get the same equal area as the area underneath the blue? So the first step is to actually find the integral, or find the area underneath this curve. So I will do so by integration. I get 9x to the negative second over negative 2 from 1 to 3. And I don't want to plug in numbers in this way, so I'm going to say it's negative 9/2 x squared from 1 to 3. That gives me a negative 9 over 3 squared is 9 times 2 is 18, minus, we're going to plug in 1, and I get negative 9/2. What that does is it gives me the answer of negative 1/2 plus 9/2, which is 4. So I want to know what value of c, okay, if I call this the c, what height, so we're going to plug in that c value into our function, will give me the same area, the area in blue. So I also need, this is the height, and I need times the base. So the base is the 3 minus 1, so it has a base length of 2. Well, I'm going to be able to go ahead and solve for this, so I'm really looking at f of c times 2, and actually let's go ahead and just divide by 2 on both sides, so I have f of c by itself. So we want to know, when is the height of this function 2? So the function itself is 9, and I'll go ahead and replace the x with a c because that's what I'm talking about, 9 over c cubed. I can then cross multiply and get 2c cubed equals 9, and then divide by 2, and I get 9/2. So my c value is the cube root of 9/2. Now if we want to know what number that is exactly, we'd have to use our calculator to compute that. So I'll do 9 divided by 2, and then I'll take the square root of that, or the cube root of that if I can on here. Looking for the button, I'm not finding it. So I'm not sure if I can do it on this one or not. So let me see if I can compute that really fast with the calculator I have laying here. Y'all just have to take my word for it, and you guys can plug it into your calculator. So we're going to take that to the 1/3 power. That gives me 1.5. Oh wait, I couldn't have put that in there right. Sorry about this. To the 1/3. That gives me 1.65. So this is approximately 1.65. So it does look to be about right here in my picture, maybe a little bit further left. But if I was to find the area of this rectangle, okay, it would equal the area underneath the curve. That's what mean value theorem for integrals says.